Okay, let's talk about our course contents. Then from today, we'll talk about a new model, regression analysis. I want to talk about what regression is, and then I want to show everyone a case study so we can learn this new model. We have been talking about prescriptive analysis, like linear programming and optimization analysis, right? But in practice, for some cases, you just don't know the constraints. Can you give me some examples? For example, you just start working at a company. You are not familiar to this company, so you don't know what constraints this company is facing, right? But you do want to analyze the relationship between some variables. For example, the customer's incomes, how the incomes influence how they spend in your store, right? You don't know the constraints, but you want to figure out the relationship between customer incomes and how much they can spend in your store. For these cases, if you don't know the constraints, but you want to identify the relationship between variables, you want to use a new model. Do you still remember the second type of model I introduced to everyone in the first class? Predictive model. Predictive. So the major difference between prescriptive and predictive is predictive does not assume that you know constraints, but you want to identify the relationships between variables. Predictive models include several types. In this course, we will focus on linear regression analysis. In other courses, you will get in touch with other models, right? But in this course, we'll focus on linear regression analysis. Linear regression is used to analyze the mathematical relationship between variables. We want to analyze how one variable is being influenced by others. So we want to call this variable in research focus dependent variable. Right? We want to see how dependent variable is influenced by others. Right? The factor being influenced, we call this factor variable dependent variable. Another name for dependent variable is response variable. Response variable. Right? But to simplify the name, in this course, we'll call dependent variable dependent variable. That's a factor we want to analyze. And then we want to analyze what factors can influence dependent variable. We call this influencing factors, predictors, or independent variables. Right? Actually, we studied these variables when we studied linear programming. We call dependent variable objective variable, right? We call independent variable decision variables. They refer to the same thing. But in order to differentiate prescriptive and predictive models, we give new terms in linear regression analysis. But they all refer to the same concept. Right? We want to know how independent variables influence dependent variables. When we use linear regression analysis, we have to pay attention to two terms, population and sample. Linear regression analysis, because it doesn't assume you know constraints. So you can analyze a group of data, not only one company, a group of company, not only one consumer, a group of consumers, right? So when we talk about the research of interest at the general micro level, we call the entire data sample population. But in practice, it's very time-consuming and sometimes impossible to analyze the entire population. For example, if you want to analyze how consumers' incomes influence their spendings in the DFW area, in DFW metro area, there are 10 million people, right? Can you survey each one of them? Impossible, time-consuming. Right? That's why we want to simplify the analysis process. We want to draw a sample from the population of research interest, which means we do not need to analyze each one of the residents living in DFW area. We just draw a sample like 100 people living in DFW area. And then we want to build an analytical model based on this 100 sample, right? Eventually, we want to use some statistical technique to analyze whether or not the model you build from the sample still hold in the population. This is the entire linear regression analysis process. You draw a sample from the population you are interested in, analyze them, build a model from the sample. Eventually, you want to use some statistical technique to predict whether the model you build from the sample still hold in the population. How smart it is. Very smart, right? Very smart. That's another reason we want to study business analytics. When you want to predict something in the population, when it's very money-consuming, time-consuming, sometimes impossible to look at the entire population, we draw a sample. And then we use the mathematical relationship to predict whether the model from the sample still holds in the population. Actually, if you don't know the subject of statistics, this process explains what statistic is, what this subject is. The subject of statistics basically teaches everyone draw a sample and then look at if the model from the sample still hold in the population. Basically, that is the purpose of the subject of statistics. Statistics look at the sample. And then we want to look at whether the mathematical relationship exists in the population as well. All good? All good? Okay. These are some terminologies I just introduced to you. Population, the group of data of your research interest, the entire group. Sample, part of a population, right? Dependent variable, the factor being influenced by others. Independent variable, the influencing factors of dependent variable. Are we all clear? Good? Very good. Next, I want to talk about the requirement of linear regression analysis. As I said, predictive models include several types. But in this course, we focus on linear regression, right? Do you still remember in chapter 1, I talked about the classification of data? We can classify data types into numerical and categorical. What is the purpose of numerical? They measure something, how big, how much, how many, how small, right? They measure things. What about the categorical variable? They classify things. Male group versus female group, right? Dallas resident versus Austin residents. They classify things. And if you want to use linear regression, you must make sure that the dependent variable is a numerical type. I want to emphasize on this point because in practice, in real research or analytical project, sometimes categorical variables are encoded as numerical format, but they are not true numerical variables. For example, gender, right? I can encode gender into 0 and 1. But are 0 and 1 real numerical variables? In this case, no. They classify things, male versus female groups. So before you use linear regression analysis, you want to make sure the dependent variable you choose are truly numerical variables. For example, incomes. Incomes can be a very good dependent variable, right? What factors can increase a person's income? Education, gender, right? What else? States where they are living. Very good, very good. You just answered one of my questions. Am I require you to have a numerical independent variables when you use linear regression? No, no. The independent variables of a linear regression analysis can be either type. I only require you to have a numerical variable as a dependent variable. You want to make sure dependent variables, the dependent variable is a true numerical variable. No requirement about the independent variables. Remember that. Can you give me other examples of dependent variable? Revenues. Revenues is a very important one too, right? Yes, very good. Remember this requirement. When you move to other classes, you will see other types of predictive models. They are suitable for categorical dependent variable. But in this class, as I said, we only talk about linear regression. And linear regression requires the dependent variable to be true numerical. Right? You shouldn't be confused by just the format as a gender example. Very good. So in this case, gender should not be analyzed by linear regression analysis because gender, yes, is encoded in numerical format, but the gender in this case does not measure, they classify. Yeah, very good. Let's see an example. So college cost is a big concern right now, right? And then we need to help a counselor in a high school. Her name is Fiona. Fiona wants to identify the relationship between the student success and how much they pay for their college education. Right? She wants to use the after salary as a factor to measure student success after graduation. Right? Okay. If you go to D2L, you should be able to download the data set. Here, I want to give you a preview. We have each school name. So obviously, school name is a categorical variable, right? We want to analyze the relationship among all U.S. universities. But as I said, it's time-consuming. We want to collect a sample of universities, and then we collect data from those universities. So the first column, school, is a categorical variable. They don't measure anything. They just plays a role as an ID, right? Second column, earnings, that's what we are interested in. The counselor wants to measure student success by using things after graduation, right? So we collect data from each school. For example, in the first university, on average, the graduate will make like $44,800 after graduation, right? Cost, how much each student pay for their education in each university. For the first university, on average, a student needs to pay $22,920. So there must be some mathematical relationship between earnings and the cost, right? We need to identify that. Yeah. We cannot just say, okay, the more expensive university will give you better earnings after you graduate from them. We cannot just say that. We need to test this hypothesis. The fourth column is graduation rate. Graduation rate. Next one, debt, student debt. And in this case, it represents the payoff percentage of student debt in each university. The last one, location, is this university a rural university or a city university? I will show everyone how to encode this variable. Because as you can see, location in this case is a numerical or categorical variable. Categorical, right? They don't measure, they just classify each university into different type. But the earnings, cost, graduation rate, debt payoff rate, these are numerical variables. We want to use a linear regression, obviously, right? Is earnings numerical variable? Yes, yes, right? They measure how much each student on average can get after graduation. So we can use linear regression for this case. And the counselor has some questions want us to answer. So the counselor is wondering what college factors influence post-college earnings and want to answer the following questions. If a college costs more or has a higher graduation rate, should a student expect to earn more after graduation? So basically, we want to analyze how cost influence earnings, right? Actually, this question contains two analyses. The first analysis is how cost influence earnings. The second one is how graduation rate influence earnings. So we have to perform the analysis respectively. Let's look at the first analysis. Let's go to D2L to download the dataset. You can download the dataset in course material, and then you should be able to see this dataset. College data. Okay, so this is the dataset. Okay, so in the first class, I showed everyone how to activate two add-ins, right? The first one is the solver add-in. The second one is called the data analysis add-in. Do you still remember? So click data on the top. Click data tab on the top. Right? Click data, and then you should be able to see data analysis. Click on it, And data analysis is mainly for predictive analysis and descriptive analysis. So in the rest of this semester, we'll focus on this at the end. Once you open this window, look for regression. Regression. And then click OK. Next, you want to select something called a Y range. In mathematics, we use the letter Y to represent dependent variables. So click on this button and then select earnings all the way to the end. We have a sample of 116 universities. We want to use this sample to represent all universities in the US. And then click the down arrow. Next, we want to select something called a X-range. In mathematics, we use letter X to represent dependent variables. So the counselor is wondering how cost influence earnings, right? So select the cost. And then check the box before labels, because as you can see, on the top row, we have cost, earnings, locations. They are considered as labels. So check labels box. And then click OK. Lots of stuff, right? Lot of results. They represent different things. Let's talk about them one by one. So once you get the result, you want to pay attention to three parts. First is something called a coefficient. Do you still remember this term, coefficient? We met this term before when we studied learning linear optimization, right? Coefficient. That is the number we should multiply before independent variable to calculate dependent variable, right? Do you still remember? I remember. I'm not sure about you, I remember. Coefficient. So according to coefficients values, we can build a mathematical model. But how did we build this model? By using a sample or a population? A sample of 116 universities. So according to this report, coefficient report, we can build a mathematical model between the dependent variable and the independent variable. It should be like this. Okay, earnings is the dependent variable, right? Earnings equals to, according to the Excel results, I want to copy these two values. Make a copy and then come back to Word. Okay. So the first coefficient is coefficient for the intercept. The value is 28,375, right? This is the value. In the future, if you see coefficient for the intercept, you don't need to multiply this number with anything. Remember that. If you see coefficient for the intercept, you simply type in this number, 28,375. Let's round the number, 0.4. Round the number to the position after the decimal point. Right? This is how you add the coefficient for the intercept into the equation. If you see coefficient for the intercept, do not multiply this coefficient with any variable. Simply the number in the equation. I will explain this number later. Okay, then you see coefficient 0.7, 0.7. This is the coefficient for the variable, the independent variable cost, right? So how can we process this number? You should do 0.7, let's round the number, multiply cost. This is how you make the reports, the results, into a mathematical equation. How did we build the model? From the sample. So this is the model from the sample. Look at this chart. If you forget, look at this chart. The smaller blue bubble, this is the model from the sample. Remember that. Please turn off your phone. I hear someone is texting. How can we use this model? Suppose someone in this sample paid, let's say, paid $50,000 for his education in a university. Eric paid $50,000 for his education in some university. According to the model from the sample, we can predict how much he can get after graduation from that university. We replace cost factor with 50,000. $0.7 multiplied 50,000. What is the number? It should be this number plus 35,000, right? Am I right or not? Good, right? That's elementary school calculation. So everybody should know. And then we want to use this number plus this number. So eventually we get this number. Right? According to our analysis, we can predict, suppose in this sample university, you have a student called Eric. He paid 50,000 for his university education. According to the model you built from the sample, he's supposed to get like $63,375 as a yearly earning after his graduation. Right? What about another student? Let's say her name is Gina, and she paid like 60,000. What should I do? Do I still use the 28,000, this number,
as the intercept for theta? Yes, very good. Because we don't multiply this number with anything, right? So no matter who this person is, we still use this number plus 0.7 multiply 60,000 now. And then we use the intercept coefficient plus 42000. So she should get like $70,000.
Right? And then we can make a conclusion that the more the student pay for their education, the higher the student's earnings will be. Can you tell me why? Why the more the student pay, the more the student will get as earnings?
So the 0.7.
Very good point, because we have a positive coefficient for the cost independent variable. Very good. It's positive, right? Do you all agree? She has a very good point. What's your name?
Because
Natika, very good point. Because the coefficient of the cost independent variable is positive. That's why the more cost you pay, the more earnings you are supposed to get from the analysis. Remember this, I will come back. Very good. This is how you use the model from the sample. I keep emphasizing the model from the sample, right? Because we'll talk about what? Population. Population is the goal for linear regression analysis. We don't care about the sample. Sample is just a stepstone for us to get closer to the population features. Remember that. This is how you use the first column. Once you get the result, this is how you use the coefficient column. You can build a model for the sample. Next, I want you to pay attention to p-values. And later in this semester, we'll figure out the mathematical logic of p-values. At this moment, you need to remember that p-values represent a probability. A probability of what? Of making a mistake if you infer the coefficient from the sample to the population. Let me repeat. P-value represents a probability of making a mistake if you assume the coefficient from the sample still exists in the population. What does this mean? As I said, we are interested in the population when we use linear regression, right? Sample is just a stepstone. So we already identified before cost, this independent variable is a positive. So we want to see the positive coefficient of cost still exists in the population. There's a chance we are making a mistake, right? There's a chance that in the population, the coefficient of cost is not positive. It could be zero, could be negative, right? But we assume that the positive coefficient of cost still exists in the population. So we need to calculate the probability of making this mistake, right? Later in this semester, we need to learn how to calculate this probability. But at this moment, you need to remember that the p-value represents this chance of making mistake that we say the positive coefficient still exists in the population. So do we want the p-value to be larger or smaller? Smaller, because the smaller the p-value is, the smaller the chance we are making a mistake. You could say, I want the probability, the p-value, to be like 5%. I could say, why not 10%? So there's a debate between people, right? So let's make a common accepted p-value, 5%. 5% is a standard. So if your p-value is less than 0.05, we can safely conclude that the relationship still exists in the population. It's just a common rule, right? You can make your p-value to be more stricter. You can see the p-value less than 0.01. I can see the relationship still exists in the population. But in this course, we just use 5%, 0.05 as a standard. So if the p-value is less than 0.05, you can see whatever you get from the sample, this relationship still exists in the population. As I said later, we need to figure out how to calculate the p-value by hands. That makes you a professional business analyst. If you just look at the software, someone asks you, how did you get this p-value? You could have trouble answering them. All good? Okay. Now in the report, we see letter E. E. E could represent two things. If you use E in mathematical analysis, E represents Euler's number. Euler is a very famous, I think, Danish mathematician. Let me write it down. In math, E represents Euler's number. Euler's neutral number. It's around 2.72. Do you still remember logarithm? Exponential operation? Remember or not? You guys are frozen. Yeah. It's a E value, 2.72. You use it for logarithm calculation, exponential, right, calculation. Very important mathematical operation. Because if you transfer the value into logarithm format or exponential format, you can use particular properties, right? Very useful. This is what E represents in math. If you see E in software, E represents 10 to the power of something. So in this case, as you can see, we see E in software, right? E represents 10 to the power of -9. You don't need to tell me the exact answer, but can you tell me what is number close to? 10 to the power of -9. 0, very good. Very close to 0. Is this less than 0.05? Yes. Yes. So we can safely say the relationship between cost and earnings we analyzed from the sample exists in the population. What is the relationship? Positive or negative? Positive, you just answered me, right? Positive relationship. So we can simply say, if the p-value of the independent variable is less than 0.05, you can see the positive relationship still exists in the population. What does this mean? That means other than these 116 universities you analyzed, you select any university from the US, which may not be in your sample, the positive influence of cost on the student earning after graduation still exists. Then you will see the more expensive the university is, the more likely the student will earn more. Right? Yes. All good? This is how you use linear regression. And I want to show you how you can formally write this conclusion.
So we look at the p-value. We said this p-value of cost is very small. We don't know the exact answer. We are not interested, by the way, because e to the power of -9 will be very close to 0. So whatever the exact answer is, we don't care. But we can see that this value, this p-value, is indefinitely close to 0. Must be less than 0.05. So we can see that based on this p-value, we conclude that the positive effect, we can see this way. Cost has a significant positive effect on student earnings.
So if you are a high school counselor, you need to recommend more expensive university to your students, right? Because this is the analysis result. Cost has a significant positive effect on student earnings after their graduations. You must emphasize the two keywords, significant and positive. Why significant? Because your p-value is less than 0.05, so your finding still exists in the population. Why positive? Because as we just analyzed, the coefficient before cost is 0.7. It's a positive number. That's why we say cost has a significant positive effect on earnings. When you work on your project, you should use the same language. This is a formal way to make a conclusion about a linear regression analysis. Can we see in the population the coefficient of cost is still 0.7? No, we cannot see that. Because every time when you change samples, your coefficient will change. However, we can conclude that the positive effect of cost exists in the population. We cannot see particularly how much cost will influence earnings, but we know the influence will be positive. Okay. What about the intercept? This value. In practice, we usually don't care about the intercept. Why? Because intercept represents a natural trend. Natural trend means it will naturally happens. Naturally happen, right? You don't consider any factor, you don't control any factor, you don't manipulate any independent variable. Student will naturally pay on average how much? So it looks like in this sample, student will naturally pay like $28,000 for their education. And this will be the natural earnings from the. I'm sorry?
The mean of the.
Yeah, the mean earnings after a student graduated from, yes, right. If you don't consider any influencing factors, naturally student will earn like $28,000. I believe that will be the most basic jobs, like delivery, food delivery, right? Like service work, very basic, naturally average, the student will earn like 28,000 if they work after graduation. This is why we really don't care about the intercept for the population. We care about some factors we can manipulate, we can manage in order to influence the dependent variable, right? Very good. Let's take a look at the result. So we look at the coefficient, we look at the p-value, right? The third factor we want to pay attention to is something called the R squared value. The formal name for R squared is coefficient of the determination. Coefficient of determination. It shows the percentage of the dependent variables change that can be explained by the selected independent variables. So we want this number to be higher, right? But the maximum value of R squared can only be 1. The lowest value could be only 0. Why? Because this number represents the percentage. The percentage of the dependent variables change. That can be explained by the independent variable or variables. Sometimes you could have more than 2 independent variables. So that's why R squared value can only be any value between 0 and 1, because it represents a percentage. Do we want the R squared value to be larger or smaller? Larger, because the larger the number is, the more percentage of the dependent variables change can be explained by the chosen independent variables. That means you accurately chooses the real influencing factors of the dependent variable. right? So here, I only use cost to predict student earnings. What if I use cost and debt payoff percentage? Do you expect the R squared value to be larger or to be smaller? To be larger. Why? Because you look at the same dependent variable from multiple angles now. You become more considerate. In other words, the more independent variables you add into your analysis, the larger the R squared value will be. This is a key feature of R squared value, or coefficient of determination. Are we all good? Any question? I'm so proud of myself. This video will become another classic tutorial video of this course. If you don't have any question. But I want to make sure you don't have question because you fully understand. Sometimes if you don't understand, you still don't have any question. I want to make sure you fully understand. Okay, we're good. Everybody's smiling, that means everybody is good, right? This is how you analyze the result. After the spring break, when we come back, we'll look at how we mathematically calculate the p-value, coefficients, R squared value, and so on. That will be a challenging topic, right? Software, very intuitive. Mathematics sometimes can be challenging. But since you choose this profession already, you need to accept the challenge. Okay. Let's try another example. Okay, I want to give everyone some time to work on the second part of this question. How graduation rate influence the student earning? Let me give you about 10 minutes so you can work on this project by yourself. And then I will show you how to perform the analysis. 10 minutes. I want you to perform the analysis in Excel. Just to follow my steps. But this time, the independent variable changes to graduation rate. In the data set, you should be able to see this new column. Correct. That will be the independent variable column. Earnings, still dependent variable columns. Try this project by yourself. Sometimes if you see me doing it, it doesn't mean you can do it. You will only know your weakness after you try it out. Let's do it together. So this time I want to click data, data analysis, regression, click OK. Y range doesn't change. X range, click the up arrow, change it to grad, right? Check label, click OK. Here it is. Can you tell me what is the model from the sample?
Copy these two numbers. If the new analysis earnings equals to
24851.15,
1.5, right? Let's round the number to 6. And then plus 329.3, round the number. Multiply once.
right?
Right, very good.
This means the higher the graduation rate a university has, the more the students from that university will earn after graduation. It makes sense, right? It makes sense. Because the higher the graduation rate is, that means the students work hard toward the graduation, not just partying and playing in college. They want to have a goal to graduate, to get the degree. So they work hard. That means they should get a higher payment after graduation. It makes sense. Next, let's look at p-value. Particularly, we look at the p-value of grad, right? It's very close to 0, less than 0.05. So we can see
How can we make a conclusion? As a significant positive effects on earnings.
this is the formal way to write the conclusion. You must pay attention to these two keywords, significant, positive. Positive represents the analysis of a coefficient. Significant represents the analysis of the p-value. Let's look at R-squared value. 0.28, 28%, which means graduation rate can explain 28% of the student earnings. If the students, let's say, increase the earnings by $1, 28% of this $1 change can be explained by the university's graduation rate. Yes. What about the other R-squared value? 28% too, right? So they both equally explain the student earnings change, 28%. In both cases, as you can see, we only use the one independent variable in each, right? If you only have one independent variable, your analysis is called a simple linear regression analysis.
What if you have more than two and more than two independent variables? Those are called multiple linear regression.
If you have more than one independent variable, your analysis is called a multiple linear regression analysis. In Excel, only in Excel, If you have more than one independent variable, those columns should be adjacent to each other.
Keyword is only in Excel.
Adjacent means next to each other. So let's say in this case, in the new analysis, I want to use cost and debt to predict earnings. What should I do? I need to move the columns around, right? I need to cut E and then paste the E next to cost. They must be adjacent to each other. This brings another topic, why you need to study more advanced software like Python and R. Because Excel is powerful, but Excel still is a very old system, right? When a person gets older, the person will have the agility issue. Right? Agility means flexibility in moving. Same thing to software. When the software is older, it's harder to operate. That's why we develop new systems like R or Python. They are for more modern data analysis. You don't have to move columns around. You have more flexibilities when you use R and Python. Yeah. That's the reason behind other courses in your degree plan. Very good. Let me show you an example of multiple linear regression. You can use as many independent variables you want in multiple. It doesn't matter. Just more than one. That will be called multiple. So in this case, I want to use cost and graduation rates at the same time to predict earnings.
Predict data and then regression. Same thing for earnings, so we don't change Y range. But we do need to change X rate. We need to select both cost and grad, right? Both of them. And then click the down arrow, check labels, click OK.
Let's look at R squared value. As I said, the more independent variables you use, the larger the R squared value will be. Now it changes to almost 40%, right? And then according to this coefficient,
What can we do? We can build a model from the sample. So earnings equals to these three numbers. Round the number. Round it. Round it again. So 0.5 is the coefficient for cost. Multiply cost. 236 multiply bread.
this is how you predict the student earning in the new analysis. This is the model from the sample. And then look at R squared values. Still, E to the 10 to the power of -6. We don't need to calculate. Very small number. So they are both significant.
And then we can make the conclusion, both cost and bread have significant positive effects earnings.
This means the positive influence are both existing in the population. Which means how you interpret this result in business language. Which means when you choose a university, you should consider a more expensive one. At the same time, you need to look at the graduation rate of that university. The higher, the better. I think that's why everybody wants to go to Harvard University, right? Stanford University. I told you it's the top three. The top three. If you want to be a tiger parent, force your kids to go to the top two or even the top one. Right? You can tell them you can go anywhere you want if you pay for it. But if you want me to pay for it, either Harvard or Stanford. That's why lots of big companies were founded by students, graduates from either Harvard University or Stanford University. If you travel, if you have nothing to do during spring break, highly recommend everyone to travel to Stanford University. Look around. Google headquarters, Apple's headquarters, Meta, NVIDIA are all around Stanford University. There is a reason. When you get older, you will see that one important thing of being a human being is change the world. Yes, getting money, yes, you want to live a good life, but if you can change the world, that's a good feeling. Do something better to make the world better. That's a very good feeling. I was usually joking with my friends. They do not understand me. Why you do research? You are a tenured full professor. Why do you still do research? I said, I wish 100 years later, when people look at my resume, they find, oh, this guy wrote a very interesting paper. Let me read it. I don't have to talk to that person. 100 years later, I'm not sure if I'm still here, but the person can still get my idea. We can have this spiritual connection. That's why I told everyone, I can write a textbook, but I don't want to. Because making money is not my concern. I want to make the world the better place. Even 100 years later, I wish some of my research can still inspire the next generation. That's what I want to do. I wish you want to do the same. Okay, since I already pushed the environment to this high, I want to stop here. Let's talk about this model after we come back.